Okay, so I'm Andrzej Lichnerowicz. I work here at Splunk since May. This will be a part of the disclaimer, by the way, in a sec. Although, besides Splunk, I've been a pretty much demo scene coder since like mid-90s, and recently I had an adventure of enlisting demo scene as intangible cultural heritage on the UNESCO list. So that's pretty much what I do. I try to write or I used to write in many languages. Recently, I focused on Zig and Golang. And at Splunk, I work in core platform, which is in part running services on Kubernetes. First disclaimer: last time there was like half of you. And this is my first public appearance since like 3 years, so no pressure. When I agreed to do this, I was like, yeah, I can handle like 20 people, sure.
Ignore them.
So that's true. So the first disclaimer: there will be a lot of macOS specific stuff, primarily Brew. Because I'm lazy, I'm not trying to make any statement and proving Apple is better because. Well, obviously. There was a saying: how can you spot an iPhone owner? You don't. He'll tell you. That's the first disclaimer. There will be a lot of Brew stuff going on. The rest is pretty much agnostic. I was just too lazy to add additional setups. The other disclaimer. This is kind of a shameless plug. I was not hired by the HR. Absolutely no. This is not an join Splunk stunt. Although we're hiring and we're a nice company. This is pretty much about like my journey here, I guess. So when I joined Splunk, I joined Splunk from Sabre. We did some Kubernetes stuff, but what I've learned at Splunk through the immersive reading of code and talking to people is something that changed my perception of how to run Kubernetes services, and this is kind of what I'm trying to share with you right now. And the biggest reason I'm talking to you today is because of one person. There's like many great people at Splunk. Again, shameless plug, but that's true. Like I had this bad narcissistic habit of thinking I'm the smartest person in the room for like many years, and I joined Splunk and I realized I'm like small. So this person is Krishnan Anantheswaran. He's a guy I absolutely had no idea who he is based on the name itself, but I suddenly discovered this is the guy behind, for example, Istanbul coverage framework. So he's a long-time open source contributor, many tools behind his belt, and he was accidentally a founding father of Kubernetes team at Splunk. And from again, kind of what he done and what he proposed as a way of running stuff is what most of the Splunk is using right now, and what I will be showing. So, what is the biggest like problem with running Kubernetes? Because like deploying the microservice itself, it's not that hard, right? I mean, there's many tutorials out there that will tell you how to deploy a simple microservice at Splunk. And you basically do this by like, YAMLs, right? Excuse me?
Bigger? Actually, with JSON.
JSON, yeah.
That's what we'll be talking about. Pretty much, because like YAMLs are fine, and for simple service, like when you have a deployment and service and maybe some config map, whatever, a few resources, it's manageable, even if you have like couple environments. But what happens if you have like 30 environments across 3 different types: staging, dev, production, and then you have different namespaces, and each environment has different traffic. Some are like low fee, some are like very busy, and you need to adjust everything. Doing this, with YAMLs is cumbersome. So the way Kubernetes team started at Splunk was with one architect that was really fond of KSonnet. And KSonnet is a orchestrating tool. Like it allows you to create and manage objects in Kubernetes. As we were talking in the break with Robert, this is one of those tools that you really want to try to use, and they're so bad that you end up writing your own. And this was pretty much same with KSonnet. What else do you have? Like, most of the world is using Helm, which is fine. It's fairly has a huge adoption. There's many Helm charts. It's pretty easy to bootstrap stuff. Helm has one issue though. It's using Go templates. And Go templates, they were basically not designed to handle YAML. Like even the name of packages where you have like HTML dash slash templates or text slash templates, they were designed for XMLs, for HTMLs, for pure text files primarily. And this is visible in a way they handle white space. Like for HTML, for XML, if you have additional like spaces or new lines, it doesn't really matter that much. For YAML, it's a deal breaker, right? If you get white space wrong, if you get the indentation wrong, like for example, if you have Go templates, sometimes you have control flow. So if something then makes something else, and then you increase indentation, then the resulting YAML breaks. If you don't increase indentation in the template, then you have everything in one line, and that looks bad and it's not readable. So basically, trying to use any of those is entering the world of pain. And this is so back to KSonnet. Sorry. So KSonnet did one thing right. KSonnet was like JSONet for Kubernetes, or Kubernetes JSONet. It was basically using JSONet under the hood. And JSONet is a portmanteau of JSON and Sonnet. It's pronounced like I said. It was done in 2014, I believe, and it was one of the 20% Google projects. And what JSONet is basically a programming language that allows you to construct JSON objects. So basically what you see up on the top is a JSONet snippet. It returns an object. First object is person 1. You can self-reference yourself. You can overwrite objects. The resulting JSON is below. A different example of JSONet shows that you can actually do functions as well. So you can have like a function person that has a default argument or an argument with default value, and you can construct the same object with 2 calls. Why JSONet is interesting to us is that out of the box you get this little nice function manifest YAML that from the very same object that we had before, we get a perfectly valid YAML file. JSONet actually can do more than that. The JSONet can do YAML. It can do TOML ini files style. It can do XML. It can do Python. It can do a number of things. And you can also do much more than I showed here, and we'll show later, because you can build libraries with JSON that you can import, and it is actually like a bundler kind of package manager. So there's a lot of pros to JSONet. Only the KSonnet tool wasn't too good on its own. And that led to creation of Quebec. And this is primarily the tool I will be showing you, the tool plus how you can handle JSON. It's for maybe not so simple, but as a stepping stone into more complex, because the application itself will be simple. There's no room to show you any complex stuff, not mentioning proprietary Splunk, but I will post this stuff to GitHub as well later on, so you might use this as a path forward. I will be showing you some conventions as well, like how I like to organize stuff, whether this is useful to you or not. We can discuss after the talk. I'd be happy to learn your experiences as well. So the application itself. Initially, I wanted to do a to-do application. It's a popular choice of example application out there, but it had some issues, and I decided to settle. The primary issues is it requires storage, and I didn't want to water down the point I was trying to make, so I picked something else. And this is a bit contrived, although please bear with me. So this is a reversed Polish notation, and this was invented by Charles Hamblin, based on Jan Łukasiewicz's Polish notation. The reason I do this little intermission is because I learned from Wikipedia writing about this that Hamblin initially proposed reverse Polish notation be called Ascivesacul notation, which is basically Łukasiewicz backwards. Fortunately, it didn't stick, but I found it interesting nevertheless. So convention number one. The way we structure most of our services is maybe not very groundbreaking, but we try to create Go module at the root and then have a source with subfolders, each subfolder being its own microservice with common dependencies. And this is easier because all the accompanying tools as well. So if we have any tools for like operators or tools to operate or tools to do maintenance tasks, for example, I don't know, like making sure the obsoleted messages on queues are deleted in case of like whatever. We had some issues, for example, where we actually had to clean up resources outside of microservice. Everything goes there. And this microservice I'm referring to, that I will not be going into much detail of, although it is working, it's also there. The other thing interesting, how the stuff is done here is extensive use of makefiles, and we also had a discussion with Robert about this. There is a tool that Robert wrote, which I learned about today, which kind of makes makefiles obsoleted and goes in the nice direction of Zig and Rust to have a build system natively in Go. But we do use makefiles, and I actually find them quite elegant. So the first trick that surprised me in the makefiles, in case you're using them themselves, is help phony target. And this is achieved by not a very like when you think of it, it's obvious, but I've outside of Splunk, I've never met anyone doing help files for make. So what this does is basically grepping itself for those comments. If you makefile list is a variable that includes all makefiles, even those included by the makefile itself. So you're grepping every makefile that is that was included in the root makefile itself for those comments, and you produce a nice screen like that. Very helpful if you have also generated makefiles. I will be showing one template generation kind of trick in makefile later on. And again, you use it like this. So the microservice. For the microservice, again, quick disclaimer. I will be using Minikube. Not that it matters a lot, but I will be using Minikube with Kimu and Docker runtime driver. And I will be using the Docker within Minikube because that's just like easier. So how do you get Quebec? It is in Splunk's open source repository. If you're using Mac, you can just tap Splunk tab. If you're not using, you probably will have to curl the binary itself from releases, and you're good to go. So what I will be showing you now, I will switch to VS Code to kind of walk you through this application and some tricks you might do in JSONet. And as I said before, I will be trying to kind of focus on the way you can achieve flexibility when creating the Kubernetes objects. And with that, I think we have, yep. So it's time for some code. And I wonder if everything won't break. So setting, let's see. Extend mirror. Okay. Am I still recording? Looks like I'm recording. Okay. Well, that's not that. So as I said, we have a microservice.
Could you increase the font size?
That is very much possible, although I need to do some. Okay, so this is simple chai router. I could use Gene. I could use Max. I think chai is, from what I've used, the simplest, and it has this advantage of using net HTTP and context natively. So it kind of plays well with Go itself. And we have like a function. We have some tests, right? So let me strip it out a little. So the way it works is basically you have okay. So one more thing. We usually try to have the CI/CD folder where we put all the pipelines, building stuff, not everything that is non-local. So as you might see in my makefile, I only have stuff that's useful locally, and then everything else it's included from CI/CD makefile. And CI/CD makefile, this is the trick I was telling you about. What this does, a little bit maybe complex when you look at it, but basically what it says is for every member of array defined here, so I might do like tool whatever, create a phony target that will be called CI underscore the name underscore image, and this target will be doing this, right? So what I'm basically saying is This is a name of the taken from here, and this dollar is the entire dependency. And what it gives me is basically I can do make CI calculator image, and it spawns. Nice. Minikube. Oh, still not here. Oh. Oh. Resolve image config for Docker. What is? Okay. I have no internet. That's fine as well. But basically, what it does is automatically creates for you all those targets. So if you have like couple services, it's very easy to create all the targets for the usage in your deployment pipelines, whether it's just like GitLab Actions, GitHub Actions, or GitLab, whatever. What else? So then when we have the Docker image build, the first file is this YAML. And here you basically define all your environments that you have. I don't have many of them, but you could add every environment you have, and you can specify namespace. You can specify additional properties for each environment. We in our clusters have a central repository for keeping all this information. So it's unified across every team and SRE as well. What else? So when we have this, there's one thing interesting here, except environments. This is post-processor. This is something that is run after every evaluation of an object, and what I'm using this for is some common annotations. I don't want to bother with providing those annotations on every single object. I'm just like doing this post-processor. There's many uses for it, but usually when we use it, it's for annotations. There's a environments folder. And with the environments folder, you can have a basic object. This is basically like a parameters. So I'm specifying all the components and the parameters for those components. So I'm like specifying how the application should be named, how service should remain, replica count, and like all different stuff. What I can do, so for in environments folder, for every environment you define, you can also define a libsonnet file with named after the environment. And what it's doing is this nice syntax of plus colon is extending an object or like overriding an object. So I can basically say like for local environment, I don't want to touch any other services, but I want my calculator to have like a replica count of 1. And that's pretty much it. And now for every component that you want, you make a subfolder in components, and you create an index, right? So what can we do here? The most simple JSONet would be. Let me backtrack a little. I think I removed too much. So let's do this one. So this will be just like we are returning this object, right? So we are returning an object with API version, etc., all the name, pod labels. This is taken from the params that we import. So we import params that I showed here. From the param map, we take component, our calculator, and we take all those and this params is already resolved for the environment that we are deploying to, right? And how can I use this is if I use Quebec and show base. Are you kidding me? Unknown variable index name again. Killed too much. Local name equals Are you kidding me?
Life demo is a risk.
Okay. So what it shows is exactly the same stuff, but evaluated for the parameters I had. As you can see, I do not specify any annotations here, but in the resulting object, we have those technology Golang type meetup annotations that I had in past processor. Where it gets funny is when you actually start having more resources, right? So one of the use cases we had is, for example, for each service we have many resources, but also not every environment has like all these resources. Let's say, I don't know, production environments might have pod disruption budgets attached, but we don't care about pod disruption budget in dev at all, right? So one interesting thing is that we can manipulate with the resources we are returning. So we can have, like, for example, dev resources, and then we have like prod being deployment and service and our pod disruption, and then returning the set of resources based on environment, or in this case, what I coded is whether the service is enabled. So if in params, if I make enabled false, then for base environment I still should get, but for local I don't, right? What else do we? What else can we do? So of course this overriding of properties for each environment, but also what we have seen is that, let's say, for when we manipulate different environments, we may wanna do per environment, but we may also want to address entire tier of parameters. The parameters for entire tier of clusters. So, for example, every cluster in stage, no matter how many we have them, we would like to have like this set of resources. And you can do this by, actually I commented out, fortunately, but let's say we want to fetch the target. This is one of the variables that Quebec is creating for us. It contains the it contains the name of the target, so base, local, etc. And we can fetch the env properties, and this maps to this thing right here, right? So I can say, I can create a function, get resources, that if we have the type defined in the properties, and type is staging, for example, then we want to do like 10 milliseconds and 100 megabytes. And if not, take whatever we had in the parameters for base or local, right? And then we can add those two objects, so objects from resources and our function. And the trick is the function, for the sake of this manipulation of objects that JSONet provides, it actually needs to be an object itself, right? Then you can merge those objects easily. And what it does is local. So we have 300 milli CPU, but if we change our env type to staging, then it's suddenly 10 and 100. And this is basically, in a very nutshell, because I was speaking faster than I thought, this is how we can create very complex, and I mean like very complex setups. The only downside to it that I know is if you let it out of control, it can easily become a Gradle versus Maven kind of thing, where you end up in a nightmarish scenario. Like, too much flexibility sometimes is not a good thing. But by using JSONets and actually centralizing a lot of environment information stuff and a lot of libraries, and that's well, I didn't show that, but JSONet has this tool that is called JB, which I probably JSONet bundler. Oh, I haven't installed it yet, but there's a bundler for JSONet that allows you to fetch libraries locally. You can also fetch them from GitHub, so you can like import a GitHub URL and or any Git repo URL basically, and it will add the library to the scope. If you really need, Quebec is also capable of importing Helm charts if there's no other way, or there's no need for any other way, and that is pretty much it. So with that, I want to open up to questions if you have any.